So I think now is the time. Well, here we have Lorenzo Miniero again, a frequent speaker here at the IIT RTC conference, chairman and co-founder of MidEco, a communication services company, and he's mostly known as the author of Janus, a general purpose and open source WebRTC server. Today is going to talk about the SFU cascading with Janus. This I think is not related to any like water related stuff, but it's more about like cascading media, I think.
Yeah.
So yeah, let's get right to it. Please, Lorenzo, go ahead.
Thanks for the introduction, Alberto, and thanks again for having me once more as part of the event. I'm always glad to present, and thank you all for attending as well. So yeah, my presentation today will be indeed about SFU cascading, so no waterfalls involved, but just some pure cascading of WebRTC streams, as we'll see in a minute. And this is just a very quick slide about me. So I'm, as Alberto said, I'm mostly known as the main author of Janus, and I co-founded a small company in the south of Italy called Miteco. I got my PhD at the University of Napoli, and here are some links that you can check if you want to learn a bit more about me or check my previous presentations. And first of all, of course, I mentioned Janus in the title, but not everybody may know what Janus is. So Janus is an open source WebRTC server that we conceived to be a general purpose one. And it's open source, as I mentioned, so you can find the code over there, plus a link to where you can find some documentations. Is my audio okay? Because I see in the chat that Hector has
Yep,
problems hearing. Okay.
it's good for me. So yeah, I don't know if I can hear it well.
Okay, then I'll just move on. Thank you. Yeah, so as I was saying, there you can find a link to demos and documentation, and we also have an active community. And one of the key components that Janus provide is an SFU component. So the SFU functionality is provided in one of the Janus plugins called the Video Room, which, as the name suggests, acts like a media relay for media on behalf of different participants using a publish-subscribe kind of approach. So somebody presents and that becomes a stream that other people can subscribe to. And of course, when it comes to cascading or in general, one of the things that does come in mind is scalability. So it's not strictly related to that, and I'll explain why in a minute, but it is indeed related. And in fact, I did touch cascading a bit in some past presentations, and this one in particular is quite interesting if you're interested in scalability with respect to Janus, a presentation that I made at ComCon. And in that presentation, I explained that whenever more than one Janus instance is involved, what we typically use a lot for scalability purposes is the so-called RTP forwarders. And so the idea is that while the Janus video room as an SFU can relay very quickly WebRTC streams to other participants, if you want to decouple the WebRTC stream from that specific Janus instance, you can indeed use RTP forwarders that basically provide you with a way to extract a plain RTP stream that the participant is sending, and then pass it to an external component, to an external UDP address, for instance. And this processor that receives the media can be something that does some manipulation on it. So I don't know, identity verification or artificial intelligence, machine learning, that kind of things. But within the context of scalability, it may also be just pass the plain RTP stream to another Janus instance for distribution. And this could be, for instance, with the help of the streaming plugin. And the streaming plugin is another component in Janus that does exactly this. It is able to receive a plain RTP stream and turn this into a WebRTC broadcast that multiple people can subscribe to. And as you can see from that image, I'm using another Janus instance as the source here, but of course, the source may be any application that understands RTP. And when we actually use RTP forwarders just for the sake of scalability, we can basically do something like this. So where you have somebody injecting a stream into the video room, so publishing their stream in the SFU uses RTP forwarders to pass them to the streaming plugin, and the streaming plugin then actually distributes media. Which, I mean, it can be done when you're doing everything with a single instance, but of course it makes more sense when you're actually using multiple instances at the same time, because then it means that you're actually decoupling the media from where it was injected and where it's actually distributed, which may be in a server where the media was not published itself. And since we are using plain RTP, it also means that you can take advantage of several different things, like plain routing of packets, or even just taking advantage of multicast, for instance, where WebRTC cannot take advantage of multicast, you can with plain RTP streams, where maybe you just publish a stream on a multicast group, and then multiple instances that can receive from that group all receive the same media, which means that in this case, you are scaling very easily thanks to the network and how it helps you in that direction. And this basically set of functionality, so the video room and streaming plugin working together, is something that we've used a lot. So we use it, for instance, for large-scale broadcasting, possibly using WIP and WEP for ingestion and distribution. And this is something that I actually presented just last year at this very conference. And in this large-scale broadcasting approach that we call Soleil, basically the idea is that you have Janus, or let's say WebRTC support at the edges, so at the ingestion, at the distribution, but in the middle it can be anything that you want. So it can be plain RTP streams that you distribute however you want, for instance. And just to come back to the main topic of the presentation, of course, scalability and plain scalability is not really the only topic. So even SFU cascading is of interest, because if we assume that we have, for instance, a conference where we have people from different areas of the world that are participating, then you have, for instance, a user from the US that is sending their contribution in the room in a server in the US, and then taking advantage of the ability of the video room to RTP forward streams to streaming plugin instances on other servers, we can do something like this. So where we ingest the stream via the video room, and so via WebRTC in the server in the US, and then from that server we feed servers in other places so that those servers can serve the other attendees via WebRTC as well. And of course, it does require a bit of orchestration, because the video room plugin is not the only plugin involved anymore. You are decoupling the management of streams using different plugins. So you are indeed responsible a bit for the signaling and the orchestration, but this does indeed work. And this is something that we use a lot in our own virtual events platform. And I won't go too much in detail about how this platform works, because there's a lot to say, but you can find the link over there. I presented it a couple of years ago at ComCon. And basically the idea is very much taking advantage of RTP forwarders as much as possible for decoupling the ingestion from the multiple servers that are responsible for distributions, and the ability to add additional servers for distributions whenever there's a need for that. And this is basically the state of the art, so how we have done things so far. The problem is that all this was conceived to work with the previous version of Janus, so the one that is still used by a lot of people, but that we now call legacy, because we actually made some improvements recently. And so that version of Janus, which was version 0x, basically had a key limitation. And I put limitation in quotes because we were never actually limited by this, but it was at a limitation in the stack nevertheless, meaning that in that version of Janus, each WebRTC per connection could only contain at maximum one audio and one video stream, which means that if you wanted to subscribe to 4 different people in a conference, then you had to create 4 different peer connections to receive media separately from each of them. And of course, this made it much easier to manage, especially as far as cascading was concerned, because again, as we've seen before, if we take into account the video room SFU for ingestion and the streaming plugin for distribution, it meant that we could basically create a one-to-one relationship between those resources. So a video room publisher on one server could be tied to a specific mount point, streaming mount point on another Janus instance, or to multiple streaming instances on different servers. And again, just because we had a very strict relationship also between a peer connection and a participant as well, which means that if I am on a separate server than the one that media is ingested on, I can still create 4 different peer connections, but with the streaming plugin rather than the video room plugin, which means that it is indeed very easily to orchestrate and negotiate, just because there is a very strict and simple relationship between those resources. The problem comes when we introduce the new version of Janus, which we call multi-stream, so version 1x of the platform, which basically removed this constraint. So now in Janus, you can have peer connections that have an undefined number of audio and video streams in the same peer connection. And so the video room SFU in particular can now be used with just 2 peer connections for a very large conference as well, because you use just 1 peer connection to send all your streams, no matter how many there are, and also a 1 peer connection to receive the contribution from all the other participants, again, no matter how many there are, which means that there is a much higher flexibility in how subscriptions are handled right now, and so also a much limited usage of network resources too. But it does present some more challenges in how to actually cascade and scale streams, as I'll show in a minute. Basically, the idea in the video room changed a bit in multi-stream Janus, and I'll show this. I'll explain how I explained how in words a few seconds ago, but maybe a picture is more helpful to understand it. So the idea is that you use 1 peer connection to send your contributions, and then 1 peer connections to receive the contributions of everybody else. And so this is true for each participant in the room. And again, this kind of approach is less easy to cascade, mostly because with this approach, we do break that one-to-one kind of relationship. Because even if, we can still create a streaming mount point on behalf of a specific publisher, it means that we wouldn't really be taking advantage of the multi-stream functionality. Because if I'm creating 3 different streaming mount points for 3 different participants, to receive those participants, I need to create 3 different peer connections. So I'm not really using the new functionality that multi-stream provides for me. And even creating one giant streaming plugin mount point that has a lot of streams in it wouldn't help either, because unlike the SFU plugin, which is very dynamic because it needs to handle participants coming and going, a streaming plugin mount point is a very static component. So you create it once at the very beginning, you tell it how many audio and video streams there will be, and that's it. It will not change, which means it's not really flexible, and it cannot adapt to actually handle different subscriptions for different people, because I may be interested in seeing 10 participants, and another participant will want to receive 9 of the same participants, but me instead of themselves. So, and this is something that the streaming plugin cannot really accommodate. And so this is why we started working on a different approach instead, which was cascading the video room plugin itself. So rather than taking advantage of this loose relationship between video room and streaming plugin, try to do that in the video room plugin itself. And we did that by basically implementing the concept of remote publishers. And very simply, the idea is that a remote publisher is a publisher that exists within the context of a video room instance. So within a specific Janus instance, but is not originated on the Janus instance, but actually comes from somewhere else. But even though this stream is coming from somewhere else, it can still be handled and advertised as part of the existing video room signaling, which means that as far as other users of the video room are concerned, this looks like a stream that is local to this instance, and so they can subscribe to it and they can interact with it pretty much as local streams are. And so this means that in a peer connection that you are creating to receive streams from people in a specific room, maybe 7 of them are coming from users that are connected to the same instances as you, and other 6 of them are coming from different sources of the network. This is something that you don't really know, because as far as you are concerned, these are all actually streams that you see as local, basically. And of course, this only works if these remote publishers can also be dynamically updated, because again, in an SFU scenario, publishers can be dynamically updated, because maybe they start with audio only, they add a webcam later on, then they start sharing their screen, then they stop sharing something else. And so this kind of dynamic approach needs to be reflected also from a remote perspective. So if a user on a remote instance has stopped publishing something, the remote instance needs to be aware of that, so that a renegotiation can take place on behalf of the local users. And all of this is done, let's say, transparently to end users, so behind the curtains. And basically, from a visual perspective, the idea is that it works like this. So this is the video room plugin as we've seen it before. So with 3 different users connected to the same instance, connected, and so interacting with each other. The concept of remote publishers is pretty much like this, where you may have, for instance, 2 different Janus instances that are working for the same concept of room. So even if they are all each responsible for their own room, as far as signaling is concerned, it's just a single room handled by both. And so in this case, we have 2 users that are connected on the Janus instance on the left that are receiving media from the green participant as well, because there is a remote publisher relationship between the two instances. And same thing for the user on the right. So the green user is still able to receive the black and yellow user, because there is a remote publisher relationship between the 2 Janus instances that is ensuring that media is forwarded accordingly. And one important thing to clarify is that we are still using RTP forwarders in this approach as well. So we haven't really reinvented the wheel. We are still reusing the same concepts we already had, but basically trying to make it a bit more integrated within the plugin rather than a looser integration. And basically, this works quite nicely in the tests that we've made, and it has been published as a pull request that people are experimenting with right now. So it is not part of the mainstream version of Janus right now, but soon will. And the idea is that at the moment, this is not really automated. And we did actually this on purpose, and for a very simple reason, because with the moment we first published Janus, for instance, we knew that we had a very interesting component in our hands, because it was very general purpose and we didn't want to constrain too many use cases with it. So we wanted people to experiment with it and come up with interesting usages of it. And this actually happened. So people started using Janus beyond what we originally envisioned it. And we thought that something like this could happen with this functionality as well, mostly because if you start automating this kind of relationship between multiple instances automatically, it means that you may not serve all the needs that people may have in mind, because people may only want to automatically create remote publishers for some users, but not all of them, or maybe only some specific instances should serve a specific publisher and other instances should serve another, which is why, at least for this first integration, we wanted to keep it simple. So basically, this kind of functionality needs to be enabled and orchestrated via the Janus API, which would also allow us to experiment a bit with it in order to first understand if there is any actual automation that can happen later on. And so the idea is that for each publisher that you want to remotize, the idea is that you first create a remote publisher on the target so that you get some connectivity info. Then you tell the source where to send the media. Sorry, did somebody ask a question? Sorry, I heard a voice.
So. Yeah, there was a voice, but that's fine. Yeah.
Okay, sorry about that. And then eventually, once this is done, you basically now have the source also available on the target machine, which means that the other Janus instance now has an avatar of that participant as well, which means that you do need to implement some manual API requests, especially for keeping track of updates, because as I said, you may have publishers that start publishing or stopping the delivery of media at any point. And this is something that the target needs to be aware of. And so this is something that a specific API request is also needed for. For RTP, instead, everything is already automated. So we basically chose a very simple SSRC multiplexing approach where we use a single port per each remote publisher. So no matter how many streams a publisher is sending, they all send it to the same port, and then we use the SSRC to figure out if it's the first audio stream, the second video stream, if simulcast is involved, and so on. Which means that even when streams are added and removed, nothing needs to be changed as far as RTP is concerned, because that's already taken care of. And of course, I mean, there is something else that needs to be dealt with as well, which is improving the performance of the video room itself. because as I've explained initially, in the current version of Janus, the previous version of Janus, we leveraged the streaming plugin for cascading and scalability purposes. And this also helped us taking advantage of the optimized broadcasting functionality of the streaming plugin itself, because the video room plugin is not really conceived to serve hundreds of participants, let's say. So it's helpful for smaller kind of rooms, while the streaming plugin is optimized for broadcasting a single stream to a wider audience instead. So it can do that via the so-called helper threads, for instance, which means that once a streaming plugin is responsible for the distribution of a specific participant, it's easier to make that participant available to a wider audience thanks to that plugin. And again, that's something that the video room plugin doesn't have. And since now the video room plugin may be responsible for this itself because of the SFU cascading that is bundled in within the plugin itself, it means that we do need to revisit the performance of the video room plugin as well, so that it can also start distributing streams to a wider audience rather than just a smaller number of participants as well, which is mainly due to some bottlenecks in some critical parts of the code due to how Janus is conceived at the moment. And this is something that we already started working on thanks to, again, to a different pull request. And basically the idea is that we are adding the same helper threads concept that we added to the streaming plugin some time ago to the video room plugin as well, so that for some specific publishers you can have some increased performance so that those publishers can be served to a wider audience of participants on a single Janus instance as well. And again, this is a pull request as well in an experimental fashion. So we hope that with additional testing and with feedback from Janus users, we'll be able to merge it soon. And that basically covers my presentation. So it was really a very quick overview of how we started, so what we were doing so far and what we are still doing versus the direction we are going to thanks to the new multi-stream functionality of Janus. And hopefully SFU cascading will benefit more people than just us, because I know that some people are already experimenting with it. So I hope that this presentation also intrigued you and will sparkle your interest, because we would definitely appreciate feedback on that. Thank you.
Thank you, Lorenzo. That was really interesting. Actually, there was a client we work with that was using Janus and wanted to achieve a little bit what you mentioned of being able to use SFU and stream plugin together. And I can totally understand those issues that you mentioned when you start with the new version of multi-stream. Those new issues happen, and you don't know really which approach to take with this upgrade. Do you have any kind of idea of why, like, the mount point, like creating a streaming mount point, doesn't work? Why is not a good approach to use that right now with the version 1 of Janus?
Yeah, the main reason is that, I mean, you can still use it the legacy way, so creating different peer connections, and that still works if you are not interested in having a single peer connection for everybody. If you do want that, then the streaming plugin is more problematic because it has a static approach. So if, for instance, you anticipate 10 people in a room, then it means that you need to pre-create a streaming plugin mount point with 10 audio streams and 10 video streams, not all of which would be filled. Not all of those seats would be filled, basically. And so you can start basically filling them in as they go. So start feeding the mount point as publishers come and go. And you can tell a user to subscribe only to some of the streams of a peer connection, so not all of them. What you cannot do is change that subscription once it's been created. So if you start subscribing just to a couple of streams because the signaling told you that only Alberto and Warren are connected, but not everybody else, then it means that when other people start joining, then you have no way to actually change the subscription to the streaming plugin to receive everybody else. You can also try to just create the subscription ones to everybody, to every single stream in that room, but that's still suboptimal because it means that you have streams that then without every negotiation involved stop sending you media or never send you media at all. It can be a bit tricky, also considering that this streaming mount point will also contain your own contribution as well, and so you need to avoid that one when subscribing. I mean, it's very tricky as far as signaling is concerned. It requires a lot of moving parts, and it's not really efficient in my opinion. So I mean, it's something that could be improved by just making the streaming plugin more flexible as well, but that would have been more of a patch rather than an actual solution. So we felt that actually providing actual cascading support to the video room to be a better solution, also because this way you can leverage the very video room API itself. So just using the video room signaling, so without having to hack any sort of wrapping functionality, you can subscribe to a user that was connected to another Janus instance instead, more or less transparently as far as the user is concerned. So the user doesn't see any difference. There is just some magic happening in the background. And so being able to take advantage of the video room signaling is definitely a big plus because it simplifies the life to many developers too.
Yeah, that makes sense. I'm very excited with those with those PRs, and yeah, we'll see if we can play with those on our end as well. I had, well, just for everyone, if you have any questions, feel free to raise your hand. There is an icon at the bottom if you want to ask some question or use the chat. I think Kaiduan has some.
It looks very cool. And Lorenzo, so one question. So you mentioned between two Janus instance, you use RTP forwarder internally, right?
Yes.
So that means the traffic is not encrypted.
Internally, I mean, it can be encrypted because RTP forwarders.
I know. Okay.
I usually call them plain RTP forwarders because they don't share the same layer, WebRTC layer. So you don't have ICE, you don't have DTLS, all those kind of things. So it's just plain RTP packets that you exchange, but we do support SDES encryption of the streams on the RTP forwarders side. So of course, it's not as robust as DTLS encryption, but since we are talking about server-to-server communication, here in this case, we assume that you have control of the keys that are exchanged via API calls using the Janus API. So in that case, it means that if you do need encryption, you can set up SDES encryption by telling the source which key to use and the target which key to expect, basically.
Yep, I forgot it. I can forget RTP forward can support SRTP. Thank you so much. Yeah, very good. Yeah. So when can we have a try? I'm excited to try it, to play around it.
It's open source, so you're definitely free to try it anytime that you want. So I may be remembering it wrong. So I think that we did merge the cascading stuff. We haven't merged the performance stuff yet. So if you use the latest version of Janus, you should already be you should already have access to the cascading functionality. So that's, and if you check the PR, there's also some API messages on how to use it, so for testing purposes. So in case you do, please do let us know if you notice any problem with it.
Thank you. Yeah.
That's great. Yep. I had a quick question. I don't know if we will have time, but yeah, wanted to know a bit about how you go to testing these large audience cascading solutions, like end to end. Like I believe you have something internally, or just.
Yeah, we haven't tested this part yet, mostly because the internal solution that we have that is called JATAC is still limited to the same limitations that Janus 0x had. So it can only do one audio, one video. So I mean, we can stress test it by just creating different subscriptions just to check if it works functionally, but we wouldn't be able to actually stress test the multi-stream version of the streams. So they are compatible with each other, so they still work. But we actually do want to test both ways sooner or later. So we first need to update our own JATAC to support multiple streams, and then we can do a fully comprehensive test as well.
Nice. Yep. Okay. Yeah. So yeah, I think with that we kind of